Okay, let's look at number 3 on chapter 8. And this one has to do with these things called fixed points. Okay, it's just kind of a cool concept. I don't know, it's kind of cool. So here's the way it works. Okay, they give us this function f of x, which is 1/2 x plus 3, simple thing, slope of 1/2, crosses the y-axis at 3. And then they say graph f of x, f of x of x, f of f of f of f of fx, right? And here is the deal. A fixed point means when is the y value equal to the x value? Well, f of x means y, right? That's the height. So we could easily say, okay, the y value is 1/2 x plus 3. And when is that equal to the x value? When is y equal x for this function? Okay, and that's called a fixed point, and you'll see why. So first, let's figure out that point. When is y equal to x? Which is when you get a fixed point, when the function is equal to x. So let's see, let's put the 1/2 x over here. So we have 3 equals x plus 1/2 x, which is 3/2 x, multiply, did I do that right? Yeah, 1/2, 1 plus 2/2, so that's 3/2. Multiply both sides by 2/3, multiply both sides by 2/3. And I feel like I'm doing something wrong. Oh, we have to take away. I need you guys to help me out here. Okay, subtract 1/2 x from both sides, right? Because this is to get rid of that. Subtract it. So we have 3 is equal to x minus 1/2 x, which is 1/2 x. Multiply both sides by 2. Okay, so x is equal to 6. X is equal to 6 is when y is equal to x. Okay, so when y is equal to x, that's equal to 6. That is what's called our fixed point, when you set the function equal to x, which is when the y value is equal to x. Now here's the deal. If you have f of x, at x equals 6, the function is equal to 6. Okay, so at f equals 6, you get f of 6. But f of 6 is 6. That's the whole point. The function of 6 is 6. So that's equal to f of 6, which is equal to 6. So no matter how we take the function of itself, well, I could do another one. F of f of f. I could go on forever. Of f of 6. You know, keep doing them. And you're always going to get 6, which gives you 6, which gives you 6. You'll always end up getting 6 because the function is equal to 6, which is the function of 6 is equal to 6. Okay, do you get the point there? So that's why it's called a fixed point. That point, all these new functions are all going to go through that point. F of x goes to that point, f of x goes to that point, f of x goes to that point. And that's kind of the explanation for part B. Because if you plug 6 in for x, that's equal to 6, and you keep eliminating all those parentheses. Okay, try it out if that doesn't make sense. Okay, so then they say to graph it. So it's actually quite easy to graph. And I did it on Desmos here because it's really easy on Desmos. But we can imagine the line itself is easy to graph. Here, actually, let's see if we can graph it without Desmos. Because actually should be easy to graph. First, once you understand the fixed point thing, which I ran over, then it's pretty easy to graph. So then so we know that 1/2 x plus 3, so it starts off, let's say 3 here is the y-intercept. And we know it always goes through 6. So here's 6, here's 6, so here's 6, here's 3. So it's always going to go through that point. And we know it has a y-intercept of 3, and a slope of 1/2. So here is one of the line. Here's the original line. Okay, it looks like that. Okay, so we know it goes through 6 because that's the fixed point. Now, if we do f of x, that's going to be f of x. We plug in f of x for x. So we have 1/2. Oh, there's an x. So you have 1/2 x plus 3 plus 3. Right? We plug in f of x for x. Now notice the slope now is just half of half. Right? The slope is just half the slope. So this is the slope. The next slope is less steep. And we know it's got to go through 6. So we just draw a slope that's a little bit less steep. That's half the slope of the original one. If we do it again, we get we plug in, if we do f of x, of x, then we just get another 1/2. We're going to get another 1/2 in front, because then we plug this thing. Basically, we take this one and plug in 1/2 x plus 3 for there. So I'm going to do that. So we have the original one, 1/2 times 1/2. Oh, there's an x. Plug in 1/2 x plus 3. We still have that plus 3, and then plus 3. We have 1/2 times 1/2 times 1/2. We have 1/8 the slope. So again, this slope gets cut in half. So the next one is going to look a little even less steep, but it's got to go through 6. So every time you do it, the slope is cut in half. It's less and less steep. It's going to go closer and closer to 0. And it always goes, but we know it goes through 6. So it's like an easy way to graph this. Okay, so we don't even need Desmos. It's pretty easy to do. You just kind of estimate the graph. Now we could figure out exactly by adding up the 3's and everything, but that's not the point. The point here is to see how these things work. Okay, so now the computation part. So then they say in C, find the fixed points of the function x squared minus 2. Okay. I don't want to do that for you because I want you to try those, but here's the idea. Okay, so I'll do a similar example. Let's say we want, okay, erase all this. Okay, so part C says find the fixed points of x squared minus 2. That's our function. They call it g, you can call it whatever you want. Okay? Now the fixed points are when the y value, and remember this is y, so y is equal to x squared minus 2. A function is just the y value, g of x, whatever is the y value. We want that equal to the x value. So now we just solve for x. Put the x over there. I think these even factor. They make it real easy for you. Okay? So that's all you do. You take your function, you set it equal to x, and solve for x. They give the answer to part C. I don't think they give the answer to part D. So then it's a little bit backwards. Now in part D they say give a quadratic function whose fixed points are -2 and 2 and 3. Okay, I'm going to do a separate example. For part D, they say -2 and 3. I'm going to do an example because I want you to be able to do this. So anyway, you should finish this one, right? It's pretty easy. Solve for x. They give you the answers, you know, if you did it right. Now they say, here we find the fixed points. Here they give us the fixed points. What's the function? If there's 2 of them, it's a quadratic. It's going to have an x squared. So if you did this one, you'll see how it works when you factor it. So basically, these are the fixed points. And okay, I'm going to do a separate example. I'm going to say, let's say 1 and -4. Okay, here's the example I'm going to do. We want fixed points of 1 and -4. So here's what you do. You say, okay, what quadratic does that work for? So you go x minus 1 and x plus 4 is equal to 0. Okay, so these are the fixed points. And so you just write it, you factor it really nice. It's really nice because you can just factor it like this. So x positive is x minus 1, negative is x plus equals 0. Now we multiply this out. So x times x is x squared, minus 1x plus 4x, the 4 wins, but so plus 3x minus 4 equals 0. Okay, now the function that does that is we need an x over here and not a 0. So we add an x to both sides. So plus x here, add an x to this side, plus x here. So then we have x squared plus 3x plus x is plus 4x minus 4 equals x. Okay, the idea of fixed points is the function equals itself, right? Y is equal to x. That's why I had to have an x over here. So what is the function that's equal to x? So this is the function. So the answer to my problem would be this, because it's when y is equal to x. Okay, so this function here has fixed points of 1 and -4 because it's equal to x. So let's try that out. So again, the tricky part is you multiply it out, get a quadratic, add x to both sides, and the function that's equal to x is the quadratic that you want. That's the function that you want because that's y was equal to x. Okay, let's try and make sure it works. What is the, let's say they asked us, find the fixed points of x squared plus 4x minus 4. Okay, what are the fixed points of that function? So this is equal to y. We want to know the fixed points of that function, so we set it equal to x. We want to know when y is equal to x. Okay, take away x from both sides. So now we have x squared plus 3x minus 4 equals 0. We want to solve for x, factor this, x minus 4, x plus 1 equals 0. So what solves that? So the fixed points are 4 and negative 1, which is what we started off with here. Wait. 1, negative 4. Did I do something wrong? Oh, it's the other way around. It's this way, right? Because we have it's plus 4 minus 1. Okay, negative 4 plus 4x minus x gives us plus 3x. Okay, so it's negative 4 and 1. Yes, negative 4 and 1, because I've got to match this, right? So the answer is we have negative 4 and 1, just like we started off with. A little bit confusing, a little bit backwards, but that's the way that works, okay? If you want the fixed points, if they give you the function, you set it equal to x, and then solve that equation for x. If they give you the fixed points, you set up the factoring, multiply it out, add x to both sides, and then the function that's equal to x is your function. Okay, I think you can do that one. Good.